Excel is still the most used program to share and visualize data within many organizations. And while Excel is an amazing tool, it also has its limitations. If you want to level up your data analysis and learn a better way to work with data, then this video is for you. I will show you how to read Excel files with Python and the Pandas library in particular. I will first briefly cover the basics and then go into more detail, showing you some practical tips. Hey everyone, welcome to the channel. My name is Dave and I make videos to help you become better at working with data. Let's get started. Okay, so before we start, there are a few requirements that we need in order to read Excel files with Python. And the first one being obviously a Python installation. So make sure Python is installed on your system. I will leave links to all of the requirements in the description. So yeah, go ahead and install Python if you don't have it already. Then secondly, we need some sort of way to run Python code, and my preferred way of doing that is Visual Studio Code. So if you don't have that already, or if you're using some other way to run Python, that is fine. But if you're new to Python, then I highly recommend installing Visual Studio Code. I also have a video about Visual Studio Code, which I will link somewhere up here. Okay, and then we need two Python packages. The first one being Pandas. So if you don't have that already, you can install it using pip, using the command over here. And the same goes for Openpyxl. You can also pip install that. So make sure you have both Pandas and Openpyxl installed. Now, if you're completely new to Python and don't know how to install packages using pip, then please check out the video that I've linked in the description. Now, once you've installed all the requirements, you can open up Visual Studio Code or any other preferred IDE of choice and create a new file. I will first quickly show you the basics and then we'll get into some more advanced tactics. If you want to follow along, there's a link in the description to a GitHub repository where I will upload this project, also including the data. I also have some other videos where I explain how I set up my Visual Studio Code for data science. That is the video over here. And I also have a video where I explain how I structure my projects. That is this one. Could be interesting if you want to follow along. For this tutorial, we'll be using 4 different Excel files. I got the data from an open source dataset on Kaggle. So this is data from a pump. So there are a lot of sensors on that pump. And our goal for today is to have a look at the data and make some plots. So here we can have a look at the folder structure. So within the main project directory, there is a folder called data. Within there, we have a folder called raw and then pump sensor data. And over there are the 4 Excel files. They are split by day. So this is from the 1st of April, 2018, 2nd of April, 3rd, and so on. And then if we open up the files in Excel, this is what it will look like. So we have a timestamp and then we have sensor 0 all the way to sensor 51. And the last column is the machine status, which indicates if the pump is running normally or if there's a defect. Okay, so now let's read this file into Python. And to start off, we'll create an empty Python file. So here I have a file readexcelfile.py, which is located over here in the source folder and then within data. So we'll start with an empty file and we'll start off by importing the Pandas module as PD. And I'll run this over here. I will run it in an interactive session. Okay, so now we have the Pandas library imported. And now we're going to use the read Excel method, which is this one over here. So Pandas has a read Excel method where we can specify the parameters and then we can read an Excel. So I'll now show you how to do that. I'm assuming you have some basic Python knowledge. Otherwise, I will refer you to my video about working with Python in VS Code. So we'll start off by declaring a variable data. And then we'll call PD, referring to the Pandas function, and then the read Excel method, opening and closing parentheses. And now we have to specify the path, and we do this between quotes. And the easiest way to get the path to a file is to right click over here on the left, click copy path, and then paste it over here, and then run this line. And then if we show the data variable, we can see that we have loaded the data. So that's quite awesome. So with just one line of code, we were able to take all of the data within this Excel file and load it into a Pandas data frame. Those are the very basics. If that's what you came here for, then this is all you need. You can also go ahead and explore the Pandas read Excel documentation on your own and find additional arguments that you can use to load and prepare the data even better. Other parameters that are very useful and that I regularly use are the sheet name, With this, you can indicate which sheet to open or to read from your Excel file if your Excel file has multiple sheets. Also, the decimal can be very beneficial because some Excel files might use a comma as a decimal separator, and that will mess up your data frame. And another very useful one is the skip rows parameter. So you can use this to give list with indexes or an int. So that is either skipping certain rows based on the index or, for example, the first 5 rows. And that could be useful for when your Excel files has some headings, for example, or some additional information that you don't want to include in your data frame. But I will now continue to show you some practical tips that I find very useful working with Excel files on a regular basis. So first, we're going to clean up this path a bit and don't use the absolute path, but the relative path. And since I'm in the data folder, which is in the source folder, I have to go up 2 directories, and then from there on I can go to data folder, raw, pump sensor data, and then here I will access the first day. Now let's run that and see if it still works. So do it again. Boom, still works. Okay, so now we're using the relative path. Then we're going to look at 2 additional parameters from the read Excel method. What you can see here is we're dealing with a timestamp. So this is a time series data set. And what I typically like to do is I like to use the timestamp and set it as an index. So that will make it easier down the road to make plots. And then the x-axis will automatically be the date. So you can make nice plots easier. So what we can do is we can go into the read Excel method and we can include the parameter index column. And what we can do with this one is we can specify which column we want to use as the index. And since it's in the first column, we'll use the 0. And now if we run this again, check it, boom, we can see that timestamp is now removed from the columns and is set as an index. So if we compare that to the data frame over here, we have an index from 0 all the way to the final row over here. And now we've set this as the index. So the timestamp as the index. Another thing that we want to do, so let me check. Let me just quickly undo that and check how the data is loaded. So if I go into here, do data info, we can see that the timestamp is, Pandas recognizes it as a datetime object. That's also very important. And sometimes this is not the case. So what we could then do, just to show you what that would look like, is we can add another parameter, and I will do that before, and that is parse dates. And here in the same way, we can specify columns which should be parsed as a date, so that it's a datetime object. We will include this as well, just to make sure. Now run it again, and then if we show the data variable, we can have a look at the timestamp, and it's corrected as the index, and it's also parsed as a date, just to force that. Let's make this all nice and clean. Call this opening a single file. By the way, the heading that I just did, I have a snippet for that using Alfred on my Mac. If I do a hashtag and then a capital H, this is what I get. So I like to use that in my code to specify the sections. But now let's just quickly explore this data. So what we can do data head 10, looks fine. We can describe the data, get some statistics. And then what else we got? We can now have another look at the info, make sure that everything has the correct data type. So as we can see, they're all float 64s here, which is to be expected except for the machine status, which is a string. So that is an object. So that is all correct. So that is a quick way to make sure the data is loaded correctly. What sometimes can happen, if you look into the Excel file over here, is people sometimes mess with the Excel files and, for example, put a letter somewhere or accidentally type somewhere. And what then happens is Pandas will read over all the columns and it will find a string variable, for example, and then it doesn't recognize it. It recognizes it as a float, and then you cannot plot it or do any numerical computations with it before converting it. So that's just a tip to check. Then what we can do a quick transformation of the data by looking at this sensor 15 over here, which basically has 0 non-null values, which basically means if we look here at the data, that it's just an empty column, and we can check that. So that doesn't add any value to our data frame. So what we can do is we can get rid of it. And we do that by using the data .drop, so pandas data frame .drop method. And then within that, we specify the column that we want to get rid of. So that would be sensor 15. And then we also have to specify the axes because we want to get rid of a column and not of a row. So that is how that works. Let me quickly check. So it's now 52 columns. Before it was 53, I guess, 53. Yeah, so we got rid of one column. And now in order to store that, we just override the data variable, save it again, then run it. And now sensor 15, that column is dropped. So if you now run the info again, if we look over here, you can see no more sensor 15. So that was a quick transformation. And then let's take a quick look at the data and plot it. Plot the data. What we can do is we can take, for example, the first sensor 0 and then create a plot. Have a look at the data over here. And just a quick heads up, I am going to import some plot settings from the utility folder over here. I also have a video on how to do this, but basically these are some style settings for matplotlib that we can import from over here. And then all we have to do is import the system, then append the parent folder to the path, and then we import these settings. And then when I plot, look, we get an instantly nice graph. So this is a very nice utility method. As mentioned, I have another video where I explain how to do this. Then we can copy paste this line and, for example, look at the second sensor, and we can already see this is quite a different type of sensor. So different range, different period. So that's interesting. All right, what else we got? We can also plot the data in a loop. So I will quickly go over this. So we can, for example, plot the first 5 columns. Import matplotlib.pyplot as plt. Make sure to spell it right. Got that. And then we can loop over it, and then we can have another look at the data. So that was basically the main objective of what we wanted to achieve. But we have looked at a single Excel file, so just for the first day. And what typically happens in a real world scenario is that people work on Excel files and they have multiple Excel files, because as you probably know, once an Excel file gets too big, your computer can't handle it anymore. It will get slow. So what you will typically see if you have to work with Excel files as an analyst or data scientist is that there are multiple Excel files. Maybe multiple logs in the case of this sensor, or financial data, for example, sales data, whatever. What we would then like to do is we would like to combine all these Excel files into a single data frame, so we can do our analysis using one script and going through it all at the same time without having to create separate files. So what I can also do is just make a copy of this file and then open up the second file and then do analysis like this. But of course, that's not what we want to do. We want to use Python instead of Excel because we want to be efficient, we want to be faster, we want to automate things. So what we will then do is we look at how to combine multiple files. So combining multiple Excel files and reading them at once. So for that, we're gonna have to import one additional library, which is called glob. You might have to pip install this as well. So from glob, we import glob. And basically how glob works is we can search a directory for specific files, file extensions, and then list those. And we can then use that to loop over them and read them into Pandas. We first specify the path where glob has to look, and so this is the data folder. So we go data and then raw and then pump sensor data. So this is the folder that we want to check, and then we want to get the files, and we do that by running glob, and then we put in the path equal sign over here. So we do path and then plus, and then this is the syntax to search for Excel files. So we basically say we want to sorry, I have to do it like this. So we combine the path that we've specified above, and then we want to search for all files that end with XLSX. So that's how glob works. So if I run this path for over here, now we have a variable with the path, and then if I run the files, we get an error because glob is not defined yet, because I have to run this first, and then we can do it like this, and then let's check what's in files. And as you can see, now we have a list. So this is a list with all the file paths. And I will now show you how we can use this to loop over them and read them into one Pandas data frame. But first, I would like to add one more thing, and that is the command sorted, or the method sorted in front of this. So I think in this file over here, it doesn't really matter because they are sorted already, but in some cases that might not be the case, and you want to make sure that your file names are sorted according to, in this example, the date. I do notice one strange thing, that there is this extra file over here, and that is probably because I have the file open. As you can see, there is a somewhat of a temporary file that is created, so make sure to close this file. I won't save it. And now this goes away. So then let me quickly rerun that. And now we have 4 instead of 5. So otherwise we would have probably gotten an error. Right, so now let's continue and loop over the files to read them into one Pandas data frame. So we're going to use a list comprehension for this. Could be pretty advanced. If you don't know what it is, you can look it up or just follow along. So what we're going to do is we do opening, closing brackets, and then we do PD read Excel, and then we specify F and also the index call. And then to be precise, we're also going to do the parse dates. Oh, let me make sure this is a comma. We do parse dates, and then we also specify the 0 column again. And then we say for F in files. So what we now have is we have basically a loop within a list comprehension. And if I run this, it will take F and loop over all those files. So those will be the 4 different Excel files that we have. And it will then call the PD read Excel function with these parameters that we specified earlier. So if I now run this, it will do this one by one, and it will basically output 4 different data frames. That's not what we want. We want to combine them. So we take this and then we call another method from the Pandas library, which is concat. So we do PD concat and then opening and closing parentheses. And if I run this, we get all the data nice into one data frame. And we can see that it starts here on the 1st of April, 12 o'clock, and it goes all the way to the 4th of April, also 12 o'clock. So now we have all the data into one file, one Pandas data frame, and then we can store this as, for example, data, call it data combined, and then save this. Let me check. So it will automatically format my code because I have black installed in VS Code. I also have a video on how to use black. Let me correct that, data combined. And as you can see, now it's all nice into one data frame. And now if we go back to the plotting section over here and we plot the data, we can see that, oh wait, for example, if you now take, I'm just gonna swap this out, probably get an error because it's not defined before, move it over here. So as you can see, now we have some more days within the data. So now we get a different picture where first sensor 0 was just this straight line, as you can see up here. Now we get some more variation. Same goes for sensor 1. We get some more clarity, and then we can loop over the first 5 columns, or even do 10, whatever. We can do it like this. And we get a nice view of the data. Now the final thing I want to show you is how to export this data frame, because what would typically happen is either you receive an Excel file from a colleague, for example, and you do some transformations and you send it back to your colleague in an Excel file. So that's what I will show you now. So export to XLSX. What we do, we take the data combined, and then we run 2 Excel. So this is a Pandas method again. And then we specify the path. So again, we go up, data, and then this time we'll do interim. So this could be an intermediate file. And then I already have it here. I say data combined, and then we run this. And then what it will do, it will take this data frame, which is a Pandas data frame, and it will export it to an Excel file. So now if you go into the interim folder over here, there is this Excel file. And if I reveal this in the Finder, we can have a look at it over here. And here you can see we have the same data frame that we just had, but now in an Excel. And notice how sensor 15 is not removed from here because we looped over the data again and we did not include this drop function over here. If we would, we could, and we would have to do that within the list comprehension loop. So then we're going to read the Excel, f index call parse dates, and then we're going to put the method at this point. And I think if we do it like this should work. So this is pretty advanced. We're doing some methods chaining over here. But now if I run the data combined and then data combined and then info to check all the columns, 15 should be gone. So then if I close this out, don't save this, and then have the data combined export to Excel again, then we go back to Excel, refill in Finder, open it up, and now it's gone. So that's how we include that as well. So if I go back and I save this, then probably Black will format this even further. But as you can see, this is getting pretty advanced. There are a couple of methods chained together, so to say, but that is exporting to Excel. So that was the first way that you would normally work. So you get an Excel, do some transformations, give an Excel back to your colleague. But a more common method, at least for my kind of work, is that you receive an Excel, you do the transformations, and then you save it to CSV, because in general, CSVs are a bit easier to handle, also less in file size. So what we can now do is we do export to CSV, and we're just gonna copy this line over here, paste it, and then we're gonna change the to Excel to CSV, and then make sure to also change the file extension, run it again, and then it will export it to CSV. I know it already was in here, but I just overwrite the file. That is because I've run this code before to test it out, of course, but reveal this in the Finder, and then we have the CSV file. We can take a look at this. If it loads, how big is it? Oh, there it goes. So now we have a CSV file. And for example, we can show this better if we open this in Sublime, for example. Let me check, have it over here. So nice and clean CSV file. So that was the final thing that I want to show you. So this turned out to be a lot more than just showing you how to read Excel files with Python. Now, if this video helped you out, I would really appreciate it if you like this video and subscribe to the channel. I'll be making more videos related to data science, Python, and machine learning. So if that's something you're interested in, you should definitely subscribe. See you next time.